In this video, we're diving into frequently asked C programming interview questions. I'll cover everything from basic concepts to more advanced topics, providing a solid foundation for your next interview. Let's begin by exploring fundamental concepts such as pointers and memory management, structures and unions, the distinction between static and dynamic memory allocation, and preprocessor directives. We will also cover advanced topics such as function pointers, bit manipulation, file handling, and multithreading in C. Let's discuss pointers in C. Pointers are variables that store memory addresses of other variables. They are fundamental to C programming and enable dynamic memory allocation, efficient parameter passing, array manipulation, and the implementation of different data structures. Consider this example. First, the declaration and initialization of an integer variable number is done with a value of 10. Then, an integer pointer ptr is declared and initialized to the address of number using the ampersand operator. Now, let us see how to access the value through the pointer, also known as dereferencing. An integer variable value is assigned the value pointed to by ptr using the asterisk operator, so value will be equal to 10. We can also modify the value of number through the pointer ptr. When we assign 20 to the memory location pointed to by ptr, the value of number will also be changed to 20. Here we'll explore memory management in C. Let us first understand the difference between malloc and calloc. Both functions allocate memory dynamically, but with key differences. Malloc allocates a single block of memory, while calloc allocates multiple blocks and initializes them to 0. Also, malloc doesn't initialize memory, so it contains garbage values, whereas calloc is slower due to initialization. Here's an example of using malloc. An integer pointer arr is assigned the address of a dynamically allocated block of memory that can hold 5 integers. The size of the allocated memory is calculated by multiplying 5 with the size of an integer. Now let us discuss memory leaks and how to prevent them. Memory leaks occur when dynamically allocated memory is not freed, causing the program to consume increasing amounts of memory over time. Here are some prevention strategies. Always free allocated memory when it is no longer needed. Use tools like Valgrind for memory leak detection. Implement proper error handling to ensure that memory is freed, even when errors occur. Here's an example of proper memory management. An integer pointer ptr is assigned the address of a dynamically allocated block of memory that can hold a single integer. After using the allocated memory, it is freed using the free function. Also, the pointer ptr is set to null to avoid it becoming a dangling pointer, which can lead to undefined behavior if dereferenced. Now, let us see the difference between structures and unions. In structures, members have separate memory locations, while in unions, all members share the same memory location. The size of a structure is the sum of all its member sizes, whereas the size of a union is the size of its largest member. You can access all structure members simultaneously, but in a union you can access only one member at a time. Structures are typically used for grouping related data, while unions are used for memory optimization. The structure point contains 2 integer members, x and y, each taking up 4 bytes. Therefore, the total size of the point structure is 8 bytes. The union data contains an integer I, a float f, and a character array str. All members share the same memory location. The size of the union is determined by the largest member, which is the character array str with 8 bytes. Now let's explore storage classes in C. Storage classes define the scope, lifetime, and visibility of variables and functions. Here's a comparison table of the different storage classes in C: auto, register, static, and extern. The auto storage class has a lifetime within the function block and is local to that block. Its default value is a garbage value. The register storage class also has a lifetime within the function block and is local to that block, with a default value of garbage value. The static storage class has a lifetime throughout the program, but is local to the block where it is defined. Its default value is 0. The extern storage class has a lifetime throughout the program and has global scope, with a default value of 0. Static variables retain their values between function calls and are initialized only once. Here, the counter function uses a static variable named count. The static variable is initialized only once when the function is first called. Each subsequent call to the counter function increments the count variable and prints its value. The output will show that the count variable retains its value between function calls, demonstrating the behavior of static variables. Let us see what preprocessor directives are. Preprocessor directives are instructions to the C preprocessor that are processed before actual compilation. They are identified by a hash symbol. Here are some key points to remember about preprocessor directives. They are not C statements and do not require a semicolon. They are processed before compilation begins. They are often used for conditional compilation. They can include files and define macros. They are not bound by the scope rules of C. Here are some common preprocessor directives. Hashtag include, which is used for file inclusion. Hashtag define, which is used for macro definitions. Hashtag ifdef and hashtag else, which are used for conditional compilation. Hashtag pragma once, which is a compiler-specific directive to ensure that a header file is included only once. Also, function-like macros can be created using hashtag define, such as the square macro, which calculates the square of a number. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.